Good morning, students. Welcome to notes for Thursday, February 23rd. We are starting Module 7, which is titled Covalent Bonding, and these are Lesson 1 notes about the covalent bond. Our focus question is, how do atoms bond in covalent molecules? If you remember last unit last module, we talked about ionic bonding, where metals would give electrons and nonmetals would take electrons, and because of that, there were charges formed. So there would be an attraction between a positive cation and a negative anion, and that would hold the atoms together in an ionic compound. That would be our type of chemical bond. Now we want to look at how do atoms bond in covalent molecules, which aren't going to be giving and taking electrons. Okay, we're going to focus on these first 3 new vocabulary terms today. So we'll talk about a covalent bond, we'll talk about what a molecule is, and then hopefully we'll get to some Lewis structures. Okay, our first review vocabulary term is chemical bond. It's the force that holds 2 atoms together. Okay. Remember last module we talked about ionic bonds, where the cation is attracted to the anion, the metal is attracted to the nonmetal because they have transferred or given and taken electrons. And that ionic bond is the attraction. That's a type of chemical bond. In this chapter or module, we're going to be talking about covalent bonds, where electrons are going to be shared between atoms, and that's another type of chemical bond, another type of force that holds 2 atoms together. Okay, when we talk about bonding, why do atoms bond? It's so that they can gain stability. What stability means is lower energy states that make the atoms, ions, or molecules more stable. For some reason, they become more stable with lower energy states. And then the second bullet here says metals and nonmetals. This is what a metal with a nonmetal will do to become more stable, to lower that energy, is they will transfer electrons to form ions with stable pseudo-noble gas configurations. So I'm going to write down an electron configuration here. Let's do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p3. Okay, if you find that quickly on the periodic table, you guys will find out that that is the element arsenic, okay, element number 33. Hopefully all you had to look for was the 4p3. And you guys can see that it's not stable. It has 5 valence electrons. So what it will do is it will gain 3 valence electrons, and it will end in 4p6, which will now give it a total of 8 valence electrons. It's not actually a noble gas. It's got a pseudo-noble gas configuration, a false noble gas configuration, because it gained 3 electrons. And that will lower the energy state, making that atom, which is now an ion, more stable. Okay, nonmetals, they're going to do something different, and this is 2 nonmetals. What they'll do is they will share valence electrons, and that allows them to acquire a stable pseudo-noble gas configuration. So if you have nonmetals, 2 elements from the right side of the periodic table, okay, to the right of the staircase, what they're going to do is they're going to share electrons in order to become stable, in order to get pseudo-noble gas electron configurations. Okay, so atoms in non-ionic compounds, they're going to share electrons. So when we talk about what is a covalent bond, if you're not in an ionic compound, you share electrons. And you form what we call a covalent bond. A covalent bond is a bond formed by sharing electrons. Covalent bonds are bonds formed by sharing electrons. And then a molecule is the smallest particle of a covalent bond. So you guys, we're going to take a look at this on a screen in just a moment. I kind of want to go through what a molecule actually is. But when we talk about covalently bonded compounds, we have to say that the little particles are molecules. And then lastly, covalent compounds, they have to form between two nonmetals. Okay, I'm going to go to a blank screen here, so I'm going to go really far ahead through the notes. And I just want to talk about a little bit about ionic bonding and covalent bonding. So if we take sodium chloride, for example, okay, NaCl, and I'm going to split that down the middle, okay? This half is a metal, this half is a nonmetal. If you have a metal and a nonmetal, that has to be an ionic compound where they're giving and taking electrons, they're forming charges, there's cations and anions being formed. And the smallest particle of this, what is the smallest piece of salt that you can have? The smallest particle is going to be called a formula unit. Remember, Fu, that's the abbreviation for formula unit. Now, water on the other hand, H2O, okay? If we split that down the middle, we know that hydrogen is actually a nonmetal. It's the only nonmetal on the metal side of the staircase. We know that oxygen is also a nonmetal. Because we have two nonmetals, we know that they can't give and take electrons. They can't form cations and anions. They have to share electrons. So we know that this is a covalent molecule, covalent bond. And the smallest particle is going to be called a molecule. Ugh. Smallest particle will be called a molecule. So you guys, water has to have these little particles called molecules. Salt has these little particles called formula units. So if you ever hear something called a molecule, you know it's made up of nonmetals that are sharing electrons. Okay, I'm going to try to get back to where I was in the slideshow here. So here I go back. Okay. So you guys, I also need you to know who the diatomic molecules are. So you might want to make a list of these diatomic molecules. They are N2, O2, F2, Cl2, Br2, I2, and H2. They are atoms that when they're found alone in nature, they are so reactive that if they have no one else to bond to, they'll bond to themselves. You need to know who the diatomic molecules are. The cool thing about these atoms is that they're found on the periodic table, these elements, and they form a nice 7, starting with the element number 7. So on the periodic table, nitrogen is number 7, oxygen's number 8, fluorine's number 9. Then we come down, we've got chlorine, number 17, 35, which is bromine. Let's wrote that out of order. Bromine, which is 35. And then we also have iodine, I think it's 53. So if you see what I see, they form a nice 7 on the periodic table, starting with element number 7. And there's supposed to be 7 diatomics, so you're actually missing 1. And if you're missing 1, you're missing hydrogen, okay? Element number 1. It is also a diatomic. It's so reactive that it can't be found alone in nature, so it will bond to itself. These diatomic molecules are also listed on your World of Chemistry info sheet. Okay, I'm going to move on. We're going to talk about single covalent bonds. A single covalent means sharing electrons. So in a single covalent bond, one pair of electrons is shared between atoms. In a single covalent bond, one pair of electrons is shared between atoms. You guys can see here, here's a hydrogen atom. It's got one valence electron. Here's a second hydrogen atom with one valence electron. If they share their valence electrons here and here in the middle, they'll both be like helium. They form a hydrogen molecule. And remember, we call it a molecule because it's two nonmetals that are sharing electrons. Okay, we're going to draw that single covalent bond. So let's go ahead and do that in our notes. So we've got a hydrogen atom here, and we've got a second hydrogen atom over here that we're adding to it. And what we do is we circle loners. So there's a loner here and a loner over here. Lone valence electrons want to pair up and be shared in between atoms. After the reaction, we end up with two hydrogens with those electrons in between both of them. I'm going to circle this hydrogen atom, who now has two electrons right by him, so he looks just like helium as far as electron configuration. And I'm going to circle this hydrogen as well. So they both have two electrons near them. They're sharing those two electrons. Another way we could draw this is we could take those two dots and turn them into a dash. A dash stands for two valence electrons. Now, what we've drawn here, I'm going to label these two. These two things that we've drawn here or here, those are single bonds. They're covalent because they're sharing electrons. But those are single covalent bonds because one pair of electrons is shared. And then we also have to remember that this is stable like helium. Because it's like a noble gas. If you get a pseudo-noble gas configuration, you are stable. So these things that we've drawn over on the right side of the arrow, those are called Lewis structures. A Lewis structure uses dots or lines. So you take dots or lines, and they're used to indicate a single covalent bond. And you guys can see with those blue arrows up there, that's what we've done. We've drawn Lewis structures. I'm going to go to the next slide. Okay, so when we talk about single bonds, what we talk about is how many unpaired electrons does an atom have in its dot diagram. So group 17 elements like the halogens, they can form one single bond with other nonmetals. If we draw the dot diagram for the element chlorine, here's chlorine with 1, 2, 3, 4, 5, 6, 7 dots. It's got one open spot. Therefore, it can form one covalent bond. If you have one unpaired electron, you will form one covalent bond. Group 16 will always form two covalent bonds. That's the oxygen family. If I draw oxygen, here's 1, 2, 3, 4, 5, 6. It's got 6 valence electrons. It has 2 unpaired electrons, okay? 2 open spots. It can form 2 single bonds. This is pretty simple. Okay, let's go to group 15. That's the nitrogen family. That's going to be able to form 3 single bonds. So here's nitrogen. It's in group 15. It's got 5 dots. There are 3 open spots. So obviously, it can form 3 single covalent bonds. And then we also have to move on to group 14. Group 14 is the carbon family. It's going to have 4 dots around it. Because they are unpaired, they don't have a partner, we can form 4 single covalent bonds. 4 bonds where we share our electron with another atom, who also is going to share 1 electron with us. Single covalent bonds. Okay, so we're going to change our definition for a Lewis structure. Again, a Lewis structure is going to use dots and lines to represent bonding and non-bonding pairs of electrons. So we have to know what a non-bonding pair is. A non-bonding pair is electrons that are not shared in a Lewis structure. We use dots. Non-bonding pairs are the electrons that are not in between two atoms. They're not shared. They're going to be on the outsides of atoms, not in between two atoms. And we're going to use dots for those. We also have something called a bonding pair. Those are electrons that are shared in a Lewis structure. And what we're going to do is we're going to use lines for those. Okay? So the electrons that appear between two atoms, we're going to turn those into a dash, a line, a single bond. Okay, let's take a look at an example. Hydrogen fluoride. I just want to show you this quickly. Some people will do this wrong. They'll draw hydrogen with its 1 dot, and they're going to add it to fluorine with its 7 dots. And what they're going to do is they're going to transfer this electron over here, giving this a +1 charge and this one a -1 charge. Here's the problem. That can't happen because both of these are nonmetals. Two nonmetals have to share electrons. Remember, hydrogen is not a metal. It's on the left side of the staircase, but it's the only nonmetal that's allowed to be on that left side. So let's take a picture, or a look at the picture of what really happens. We're going to have hydrogen with its 1 valence electron. We've got fluorine with its 7 valence electrons. And what we do is we circle lone electrons, single electrons. So I've got 1 over here, and I've got 1 here. Those two can be shared in between the hydrogen and the fluorine atom. So when I draw my finished picture, I'm going to draw my hydrogen with fluorine, and they're going to share those 2 electrons, the 2 that I circled. And then I'm going to have to make sure that I account for these other 6 electrons. They only belong to fluorine, so I'm going to stick the other 6 electrons on the outside of fluorine. The next thing I'm going to do is I'm going to circle my 8 electrons. Okay, there's 2 for hydrogen because it's like helium, so it's stable. Fluorine has 8 valence electrons. It's like a noble gas. It's stable. And then I'm going to transfer my picture, and I'm going to change those shared pairs to a dash. Remember, shared pairs, bonding pairs, turn into a dash. So what I have here in the finished picture is here and here. Those are single bonds, but there's some other terminology that I need to know. I need to know that these electrons here, okay, and let me circle those in blue. These guys here, those are non-bonding pairs. And then you guys, in here, that's a bonding pair that forms the single bond. Okay, hitting the home stretch here. One thing that we have not talked about, you guys, is double and triple bonds. We're going to do an example on the worksheet that you guys have to do. But in a double bond, you would share 4 electrons, 2 pairs. And in a triple bond, you would share 6 electrons, or 3 pairs. We're going to do problems 1, 2, and 4. We're not going to do all of these. Let's do 1, 2, and 4 on page 200. So if you're on page 200, problem 1 wants us to draw the Lewis structure for pH3. We'll learn how to name these later in this module. So here's what you guys need to remember. The atom that forms the most covalent bonds has to be in the center of the picture. So you guys, phosphorus and hydrogen, I'm going to draw one of each of them. Hydrogen has 1 dot. Phosphorus has 5 dots. I'm going to make my phosphorus a little bit neater. Maybe my hydrogen as well. So you guys, here's what I know. Because phosphorus has, I only need 5 dots for phosphorus. Because phosphorus has 5 dots, it can form 3 bonds in those open spaces. Hydrogen can only form 1 bond because it only needs 1 to be like helium. Okay? So I'm going to draw another hydrogen and another hydrogen. Remember, our formula was pH 3. I can circle these guys, and I can circle these guys. It's pretty simple. Okay, in my next picture, this is after the reaction, I can draw that P with an H above it sharing, an H over on the left side sharing, and an H on the bottom sharing. But I can't forget about these electrons over here that only belong to phosphorus. So I'm going to tack those on the right side. The next thing we do is we circle stable atoms with their electrons. So there's 2 for that hydrogen. There's 2 for that hydrogen. There's 2 for that hydrogen. They're all like helium, they're stable. And then I also have to circle the 8 for phosphorus, which make it have a pseudo-noble gas configuration. And then the last thing I'll do is I'm going to turn my bonding pair into a dash. Those 2 electrons in the center turn into a dash. Okay? I've also got a bonding pair here and a bonding pair here. And then I've got a non-bonding pair over here. And that's my finished product. Okay, let's try number 2. Number 2 wants us to write the Lewis, or draw the Lewis structure for H2S. Obviously, sulfur is going to have to be in the middle. It's got 6 dots. I'm going to put a hydrogen here and a hydrogen here. I'm going to circle loners. There's 1 there, 1 there, 1 here, 1 here. Remember, you're always circling loners between the central atom and the outside atoms. Don't try to put the outside atoms together. Okay, after the reaction, I'm going to need to draw my S in the middle. I'm going to put dots. We're going to do dots first. So I'm going to do dots between this sulfur and this hydrogen, and then dots between this sulfur and this hydrogen. And then remember that sulfur has 2 pair of dots that aren't shared. The next thing I'm going to do is circle. This guy's stable, this guy's stable, and now this guy's stable with his octet. And then I'm going to finish the drawing over here with the actual Lewis structure, where those shared pairs, the pairs between atoms, those are going to become dashes. I hope this makes sense. One quick thing. Again, that's a shared pair. And then over here, these are unshared pairs. Remember, the shared pairs, they turn into lines. Okay, last one I want to do is number 4. I know this video is getting a little long. So 4 is the last one. And 4 says CCl4. This is going to be a fun one. Carbon's going to go in the middle. It forms 4 bonds. And then I'm going to put a Cl with 7 dots on every side. Remember, I have to circle loners. So I'm going to circle this loner and this loner. I can do this loner and this loner. I can do this loner and this loner. And then I can do this loner down here with this loner here. Then the next thing I do is I'm going to take those red circlings of 2 and I'm going to put them in between. Those are my shared pairs. I'm going to neaten that up a little. But then we also have to remember that there are some unshared pairs. I think each chlorine has 3 unshared pairs. Okay, no worries. Then I've got to do some circling. I'm going to circle the 8 here in the center for carbon first. Then I'm going to circle the 8 for this chlorine, the 8 for this chlorine, the 8 for this chlorine, and the 8 for this chlorine. Okay, no worries. And then I have to change my picture to the actual Lewis structure, where I change the shared pairs in the intersections of those circles to lines. Now I got a lot of work left to do because there's 3 unshared pairs left on each chlorine. And there you have it. We can probably do 3 and 5 and probably 6 on Monday as a little review, but that's Lewis structures. So the last thing I'd like to do is I'd like to do one off the worksheet for today. And the one I'd like to do off the worksheet is let's do F. F is probably the hardest one on the worksheet. So here we go with F. F is HCN. Okay, if you draw one of each with their dot structures, we find out that carbon has the most lone electrons, singles. It's going to form the most bonds. It has to be in the center. And then I circle loners between the center atom and the outside atoms. Hydrogen's done. But I've got 3 lone electrons on carbon, and I've got 3 lone electrons on nitrogen. Why wouldn't I circle those? So you guys, I hope you can see what's happening here. What we're going to do is, in between the carbon and the hydrogen and the nitrogen, I'm going to put those electrons. So I'm going to do carbon to hydrogen. There's 2 electrons. Okay. In between carbon and nitrogen, we circled a total of 6 electrons. I hope that makes sense. And then you guys, there's 1 unshared pair out here on the right of nitrogen. Now I'm going to circle my stable atoms. Here's 2 for hydrogen. You guys, you got to be careful. Here's 6 plus 2 for nitrogen. Those are all near nitrogen. They're being shared between carbon and nitrogen. And then carbon, we're going to circle those 8 electrons. Okay, I'm going to come over here to draw it in the next picture. And I'm going to draw a line here. Here I'm going to draw 3 lines for 6 electrons. And then I'm going to put my nitrogen over here. If you take a look at it, everybody is stable with either 8 or 2 electrons for the hydrogen. That's the end of notes for today, and I'll see you on Monday.